Are you curious about how your car can produce more power without having to increase the engine's size? Well, the answer lies in the magic of turbochargers. Turbochargers have become increasingly popular in the automotive industry due to their ability to boost the engine's performance. But how do they work, and what are the different types available? In this video, we'll be exploring the world of turbochargers and explaining how single-scroll, twin-scroll, variable geometry, and electric turbochargers work. By the end of this video, you'll have a better understanding of how turbochargers work and which type may be right for your vehicle. So buckle up and let's dive into the fascinating world of turbochargers. A turbocharger is a device that compresses the air that goes into the engine, allowing for more oxygen to mix with fuel and create a bigger explosion inside the engine. This results in more power output, making the car faster and more responsive. Turbochargers work by using the exhaust gases that are produced by the engine to spin a turbine, which in turn spins a compressor wheel. The compressor wheel draws in fresh air and compresses it before delivering it to the engine. The process starts with the exhaust gases flowing out of the engine and into the turbocharger's turbine. As the gases pass through the turbine, they spin it at high speeds. This spinning motion is transferred to the compressor wheel, which is connected to the turbine via a shaft. The compressor wheel then draws in air and compresses it before delivering it to the engine through the intake manifold. The turbocharger is driven by the engine's exhaust gases, so it doesn't require any external power source to function. This makes it a very efficient way of increasing an engine's power output without adding any extra weight or complexity to the engine. Turbochargers are commonly used in high-performance cars, trucks, and other vehicles that require more power than a naturally aspirated engine can provide. One of the main advantages of a turbocharger is that it allows for smaller, more efficient engines to produce the same amount of power as larger, less efficient engines. This can result in better fuel economy and lower emissions, making turbocharged engines more environmentally friendly than their naturally aspirated counterparts. However, turbochargers can also have some disadvantages, such as increased complexity and potential for lag. We'll explore these further in the following sections. A single-scroll turbocharger is the simplest and most common type of turbocharger. It uses a single inlet to feed exhaust gases to the turbine and a single outlet to connect the compressor to the engine's intake manifold. The advantage of a single-scroll turbocharger is its simplicity, which makes it more affordable and easier to install than other types of turbochargers. The downside of a single-scroll turbocharger is that it can only efficiently boost the engine's power output at high RPMs. This is because the exhaust gases from each cylinder have to compete for space in the single inlet, which can result in reduced flow rates and increased turbo lag at lower RPMs. Additionally, a single-scroll turbocharger can cause uneven flow of exhaust gases between cylinders, which can lead to reduced engine performance and increased wear and tear. Despite these limitations, single-scroll turbochargers are still widely used in many high-performance cars, such as the Subaru WRX and the Mitsubishi Evolution. They are especially popular in applications where cost and simplicity are more important than optimal performance at all RPM ranges. Overall, a single-scroll turbocharger is a reliable and cost-effective way of increasing an engine's power output, but it may not be the best choice for those who prioritize low-end torque and quick spool-up times. If you're looking for better performance at all RPM ranges, you may want to consider a twin-scroll or variable geometry turbocharger, which we'll explore in the following sections. A twin-scroll turbocharger is a type of turbocharger that uses two separate inlets and outlets to feed exhaust gases to the turbine and the compressor. By separating the exhaust gases from the engine's cylinders into two distinct paths, a twin-scroll turbocharger can reduce turbo lag and improve low-end torque. The two inlets are designed to separate the exhaust gases from the cylinders that are 180 degrees apart in the engine's firing order. This separation allows the turbocharger to better utilize the energy from the exhaust gases, which can result in faster spool-up times and better low-end torque. The advantage of a twin-scroll turbocharger over a single-scroll turbocharger is that it can provide better performance at all RPM ranges. The improved low-end torque and reduced turbo lag make twin-scroll turbochargers popular in applications where quick acceleration and responsiveness are desired, such as in sports cars and performance sedans. However, the design of a twin-scroll turbocharger is more complex than a single-scroll turbocharger, which can result in increased cost and installation complexity. Additionally, the separate exhaust paths can result in uneven exhaust gas flow between cylinders if not designed correctly, which can lead to reduced engine performance and increased wear and tear. Overall, a twin-scroll turbocharger is a great choice for those who prioritize low-end torque and quick spool-up times. It's more complex and expensive than a single-scroll turbocharger, but the improved performance may be worth the investment. A variable geometry turbocharger, VGT, is a type of turbocharger that has variable turbine geometry. This means that the angle of the turbine vanes can be adjusted to optimize the flow of exhaust gases to the turbine and compressor wheel. By adjusting the vanes, the VGT can maintain optimal boost pressure at all engine speeds, which can result in better performance and improved fuel efficiency. The VGT's variable geometry is controlled by an actuator that responds to the engine's operating conditions, such as engine speed and load. When the engine is operating at low speeds, the VGT's vanes are adjusted to narrow the turbine's diameter, which results in faster spool-up times and reduced turbo lag. At high speeds, the vanes are opened to increase the turbine's diameter, which can provide higher boost pressures and better top-end performance. The advantages of a VGT over other types of turbochargers are improved low-end torque, reduced turbo lag, and better overall performance. Additionally, a VGT can be more efficient than other types of turbochargers because it can maintain optimal boost pressure at all engine speeds, which can result in better fuel economy. However, the VGT's variable geometry design is more complex and expensive than other types of turbochargers, which can result in increased maintenance costs. Additionally, the VGT's actuator can be sensitive to engine heat and vibration, which can lead to reliability issues if not properly designed and installed. Overall, a VGT is a great choice for those who prioritize optimal performance at all engine speeds and improved fuel efficiency. It's more complex and expensive than other types of turbochargers, but the benefits may be worth the investment. An electric turbocharger is a relatively new type of turbocharger that uses an electric motor to spin the compressor wheel instead of relying on exhaust gases to spin the turbine. The electric motor is powered by the car's electrical system, and it can be activated instantly to provide immediate boost pressure without any lag. The advantage of an electric turbocharger is that it can provide instant boost pressure, which can result in improved acceleration and responsiveness. Additionally, an electric turbocharger is not dependent on exhaust gases, so it can be used in hybrid or electric vehicles that don't produce enough exhaust gas to spin a traditional turbocharger. However, the electric turbocharger's main disadvantage is that it requires a significant amount of electrical power to operate, which can put a strain on the car's electrical system. Additionally, the added weight and complexity of the electric motor can result in increased installation complexity and cost. Overall, an electric turbocharger is a great choice for those who prioritize immediate boost pressure and are willing to invest in the additional electrical power required to operate it. It's a relatively new technology that is still being developed, so we can expect to see more improvements and applications of electric turbochargers in the future. In conclusion, turbochargers are a fascinating piece of technology that can greatly enhance an engine's performance. Whether you choose a single-scroll, twin-scroll, variable geometry, or electric turbocharger, each type has its own unique advantages and disadvantages. By understanding how turbochargers work and the different types available, you can make an informed decision when choosing a turbocharger for your vehicle. Whether you prioritize low-end torque, quick spool-up times, or immediate boost pressure, there's a turbocharger out there that's perfect for your needs. We hope you enjoyed this video and learned something new about turbochargers. If you have any questions or comments, feel free to leave them below. And if you found this video informative, please consider sharing it with your friends who are interested in learning more about turbochargers. Thank you for watching, and we'll see you in the next video.